Module 15.5, division of division of radical expression. Another way of saying dividing radical expression is something called the rationalizing denominators. So, this particular section, 15.5, has two types of division problems. One of them, which is what we're going to go over to in this video, is where the denominator only consists of one term. So to rationalize a denominator containing a square root or cube roots, number one, if the denominator contains a square root, multiply both the numerator and denominator by an expression that will give a denominator with no square root. Alright, number two, just saying exactly the same thing as changing square root to cube root. So what is that saying? So basically, this is kind of very strange. A little bit of manipulation going on. Rationalize a denominator. The reason why we rationalize the denominator is because we do not want any sort of radical in the denominator. There's no radical in the denominator. Alright, so when you look at this square root of 7, this square root should not be down here. So how do I get rid of the square root? The trick we're going to do is take a look at how many more 7 do I need so I can have a 7 squared, because square and square root will cancel out. So since I already got 1 7 in my square root, what I can do is multiply another square root of 7. Because now square root of 7 times square root of 7 is actually square root of 7 squared, or you can say square root of 49. Either way, the square and square root will cancel out, so that will leave me just with a 7 in the bottom. But I cannot just multiply a square root of 7 out of nowhere. So the trick is multiply what I need to get rid of my radical in my numerator and the denominator, because this is still equivalent of 1. So this is legit. Alright, so now I'm going to multiply square root of 7 over square root of 7. So the bottom now becomes 7. The top is simply just 4 times square root of 7, which is 4 times square root of 7. And that's my answer. Okay, no more radical in the denominator. And most of the time we prefer everything to be one term. Once in a while, I could have multiple terms up top, shares the same LCD or same denominator. That will be fine. It just, from time to time, when we run into those type of answers, we might have to split them up into a couple terms. Okay, and I will show you when we run into them. Now, this problem, these two is slightly different. Okay, I do have a square root of 3 in the bottom, which is a no-no down there. All right, but since I also have a square root on the numerator, what I can do, which is something I showed y'all back in 15.2, if I have a square root of a over b, all right, what I can do is split them into two separate radicals with the same roots. So now, if I have two separate radicals with the same roots, I can actually put them back, okay, under the same square roots, under the same roof. So I'm going to rewrite this as a big old square root of 96 over 3. And the reason why I'm doing that, so I can actually reduce my 96 and 3, because 96 divided by 3 is exactly 32. So when I have this 32, that means my denominator is now 1. Okay, and I'm still inside the square root. So square root of 1 is just 1. So basically here I'm just going to write a single square root of 32. And we can actually break it down from here. So most of y'all probably say, oh, 32 we can break it down by 2's, or some students will say this is 16 times 2. Square root of 16 is 4. Either way, my final answer is 4 times square root of 2. Okay, So we can, again, we can use perfect square number to go into 32, or we can break down 32. This is 16. So 16 square root of 16 is 4. So you can do it that way. Okay. So many different ways to do this. Okay, to simplify our radical. All right, let's try the same thing here. Okay, I noticed that 21 and 77 can actually be reduced. So I'm going to write a big old square root. This is 21 over 77. So I can reduce them by 3. So that will give me square root of 7 over 11. So now, okay, what do I do now? Now I'm going to split them apart again. So having a radical in the denominator is a no-no. So I'm going to multiply. All right, what do I need to get rid of my square root down here? I already got 111, so all I need is another square root of 11 over square root of 11. Because now my denominator is square root of 11 times 11, which is squared. And square root cancel out. That leaves me with just 11 in the bottom. So my top, square root of 7 times square root of 11 will be square root of 77. Just like multiplication. Inside multiply inside, outside multiply with outside. With fraction, okay, inside reduced with inside, outside reduced with the outside. So 77 is inside, 11 is on the outside. They cannot be reduced. Okay, so this must be my answer. All right, this is a cube. This is actually a cube root. So let's use this. Let's do this problem the same way as the previous two, because I'm going to simplify what I can before I split them again. Or, I'm writing the step down. Some students just go ahead and do it while they're in there, which is fine. 54 and 10 reduced. If you want to, you can put it in your calculator. Let's do that. 54 divided by 10, convert into a fraction. So that's 27 over 5. And this is nice because cube roots, let's split them up now. This is cube root of 27 over cube root of 5. We know cube root of 27 is simply a 3, right? Over cube root of 5. Alright, now having this radical down here in the denominator is a no-no. So, since I already got 1 5 inside the cube root, all I need is 2 more 5. All I need is 2 more of these 5 to get rid of the cube roots. Right? Because I already got 1. I just need 2 more. So I will multiply cube root of 5 squared, top and bottom. And I purposely write it as square. So now we can see cube root of 5 times cube root of 5 squared should give me cube root of 5 to the third. So cube and cube root will cancel out. My denominator will simply be a 5. So my numerator, these two 5 can't go out, the cube root. So we just multiply them. So that gives me 3 times cube root of 25. Okay, that will be it. Outside and outside can reduce. Well, not this problem. Outside, inside cannot be reduced. All right, what happens if I have 2 factors inside my radical that's in the denominator? Well, same thing. I just need to multiply. Well, I got 171y already. To go outside the square root, I just need 1 more 7 and 1 more y. So that's what we multiply on the numerator and the denominator. So basically my denominator now is square root. And if you want to, I'm going to purposely write it differently. This is same thing multiplied together, so I can write them as whole things squared. Because again, square and square root cancel out. That just leaves me with 7y in the bottom. All right, the top, 7 times square root of 7y. So the outside 7 and the outside 7 can be reduced. So my final answer would just be square root of 7y over y. All right. So when it comes to rationalize a denominator, where the denominator only consists of one term, okay, all we needed is to figure out how many more radicand do I need to cancel out my square root or my cube root. And then that's what I multiply for my numerator and denominator. And then we simplify from there. All right, that will conclude this lecture video. Thank you for watching.